Hello guys, we have a question on the screen which is on space and solar system. That's for paper 2. A main sequence star in a distant galaxy is the same size and mass as the sun. Explain why the star is stable while it is in the main sequence stage of its life cycle. Now, the life cycle of a star, right from its birth to the point where it gets to a black hole, runs over billions of years. All right, then coming back to this question now, saying explain why the star is stable while it's in the main sequence stage. The main sequence stage is the most stable stage in the life cycle of a star. In fact, our sun is in its main sequence stage. Now, what happens at the main sequence stage? You've got two forces acting on it. Number one is the gravitational force, and the gravitational force acts inwards. The gravitational force acts inwards, and forces as a result, that's of nuclear fusion, of fusion reactions outwards are hereby in equilibrium. The gravitational force is responsible for pulling the mass of the star inwards, more like kind of like collapsing it, and then the nuclear fusion supplies the energy, supplies the light by hydrogen molecules combining together to form helium molecules in that stage of the star's life cycle. Now, moving on, the second question says, describe what will happen to the star between the main sequence stage and the end of the star's life cycle. If the star is the same size as the sun, this is the key here. If it's the same size as the sun, it's going to form a red giant. If it's not the same size as the sun, it's going to form a red supergiant. So here we go with the red giant. The star will expand to become a red giant. Then it will collapse to become a white dwarf. And then lastly, after that, the star will finally cool to become a black dwarf. So that's that for that particular question. And then figure 5 says it shows how the speed of galaxies moving away from Earth varies with the distance of the galaxies from Earth. You have the graph for the speed of galaxy moving away from Earth on the y-axis, and then the distance of galaxy from Earth on the x-axis. Now, what's the question saying here? It says, which galaxy will show the smallest observed change in the wavelength of the visible light? Now, you have four galaxies here. You've got A, B, C, D. The one closest to the Earth will actually show the smallest change. You know, the redshift is when you've got galaxies moving really far away from Earth, and then when you observe, the galaxy or the star will appear redder than it usually would, and that's because of the stretching of the red spectrum of the wave length. So here now, the one closest to us is A, and that's the reason that will show the smallest observable change. Is the closest to Earth